All right, so these last three sections in chapter 4, they might sound scary when I say the word or the phrase word problems, as you see up there. I will tell you though, I feel that in my experience, students actually find these much more straightforward even than the ones we were doing back in chapter 2, once you understand how to kind of adapt this process that we used, Ruvessa, to the word problems. So I've got the 3 different sections broken up here. Each one is a very specific kind of word problem. So once you can identify it, you then know kind of how to tweak Ruvessa, how to use it to your advantage to knock out the word problem. Now Ruvessa pretty much stands for the same thing it did in chapter 2. R stands for read. U stands for the listing of the unknowns. It's nice to know in these sections we're going to always have 2, guaranteed 2 things you don't know the value of. Now V is interesting because V did stand for variable, where we had to take a lot of time and figure out which of our unknowns could be our X, and then how to describe the other one in terms of X. It's actually much easier here. In chapter 4, when you're using this V step of variables, you'll have listed your 2 unknowns, and then we will immediately just give each unknown a different variable. I'll always stick with X and Y. But there'll be very little thought, very little time spent on this V step. Now the E step is a little more involved in that rather than writing 1 equation like we used to, we will write 2 equations because we'll have 2 variables, so we'll need 2 equations. However, again, as we look at these 3 sections, you're going to see that each section's word problem has a very specific way you're going to want to approach kind of the idea of where those equations come from. In fact, this first one may be the trickiest of all of them, I would have to imagine. But then once you've got those equations, the solving will just involve whichever process we're going to use, substitution or elimination, that we've been using here in chapter 4. But then the answering will boil down to understanding what those values of X and Y mean. We won't be writing coordinate points like we were here, not X and Y points, but we'll actually be interpreting those numbers as answers with units and an understanding of what they represent. So that is what we're going to do here. Let's go ahead and jump in and see how Ruvessa works in our first word problem. So Nick wants to create a rectangular room for his friend Bruce, and he knows he has 54 feet of titanium for the perimeter. The length is to be 3 feet less than 2 times the width. Find the dimensions of the room. Answer in a complete sentence. All right, well, we have read it, so mark that off. So the U step, the unknowns. All right, the first thing we do is I just label that we're going to be listing our unknowns, and in this case, there are 2 of them. We always know there's 2 of them in this chapter. And looking at our rectangle, and looking at the fact that we know information about the length and the width, but we don't know either value, in the question or the statement, find the dimensions. Dimensions of, in this case, a rectangle, are basically like saying find the length and the width. That's what we want. So our 2 unknowns are length and width. That's it. That is all we do, or what I consider the U step, the unknowns step. Now the V step for variable, like I said, super simple. I'm going to call one of these X, one of these Y, and move on. Now that I have that organization though, now I know how to refer to the length and the width in the 2 equations I go to create. Okay? So of the 2 equations, one is going to come from this phrase right here that is basically directly comparing our 2 unknowns. The length is to be 3 feet less than 2 times the width. Cut out just a couple extra words in there, and it says the length is 3 less than 2 times the width. So to translate that, when I see the phrase the length, that's what I'm calling X. So the length is, we've always learned that is stands for our equal sign. Now this was a little tricky phrase. 3 less than 2 times the width. Remember 3 less than does mean subtraction, or less than means subtraction. But 3 less than anything, 3 less than something means you're subtracting 3 from it. That was our tricky translation phrase that put subtraction with that thing at the end. So 3 less than, but now here, 2 times the width. If we're calling our width Y, then 2 times Y is simply 2Y. And so we have the length is 3 less than 2 times the width. Now, we need a second equation. With 2 variables, you have to get 2 equations. So there is one of them. Now, the other one will come from the piece of information we haven't used yet, which was up here, that we have 54 feet of titanium for the perimeter. So they even tell us. And so we just need to remember our perimeter formula. Now, just as a reminder, off to the side here, our perimeter formula for a rectangle was P equals 2L plus 2W. So I'm going to use this formula, but for the perimeter, that's a number they've given me. So I've got 54 for that perimeter equals, and then 2L plus 2W. I'm not going to use L and W because I've got my variables I want to use for length and width right there. So 2x for length plus 2 times the y for the width. And with that, we've set up the word problem. Basically getting to here, right, you've now got your system in front of you. The word problem's done until you get to your final answer and you're interpreting those numbers. Because the S step of solve is nothing more than picking one of our methods to solve this. And in this case, for these equations, since we've got one equation already in the form x equals, right, solved for a variable, that's a good indication or a good hint to say, let's use substitution. X is the same as that expression right there, so we can replace or substitute that expression directly in for that x in the second equation. So I'm going to have 54 equals 2 times, but now in place of that x, I'm putting the entire 2y minus 3. And then finish the rest of the equation there, plus 2y. So that equation with that plugged in, that's substituted, and now we can solve it. It's an equation with only y's in it. So do things like distribute 4y minus 6 is all it takes to clear those parentheses with those terms. Then I've got a couple like terms I can combine right there, a couple y terms. 54 equals, if I combine 2y and 4y, that'll be 6y minus 6. Now, at this point, we will get the constants to one side since the variables are already on the other. 64 and a plus 6 gives me 60. And then on the right side there, still have 6y. And then get the y by itself, dividing by 6 to get y equals 10. So there's our first variable, and with that, because we use the substitution method, remember, this is where it's nice and convenient that with this equation, we've got to solve for x. We can take that value of y, plug it right in there, replace it. Not a whole lot of work except just evaluating that right-hand side to get our variable for x, our value for x. And at this point, if I can keep the word problem there on the screen, we again know what x and y stand for. We mention it right here. And the directions say find the dimensions. So that's what we want, are those two numbers interpreted for this problem. Since we're talking in feet, that's important to notice. So we can say something like the length is, so the length was x is 17, so 17 feet. And the width is, well, the width was y, and y is 10. So 10 feet. There we go.